We would like to introduce our high-efficient hybrid power system for portable electronics in DAC University booth. We are from Embedded Low Power Lab at Seoul National University.
Almost all portable electronics of today, such as laptop computer, MP3 player, and cellular phone, rely on batteries for power supply. Those devices are powered only by the battery, and the battery is charged from an external power source. It is simple, but unfortunately energy inefficient in many ways. We usually charge batteries from the utility power, or USB power from computers. These powers are often considered as free. However, it is not always true. Furthermore, dynamic load current fluctuation causes reduced net energy delivered from the battery due to the rate capacity effect. Using a hybrid power source can help overcome these problems. A hybrid power source consists of multiple heterogeneous power sources, such as batteries, supercapacitors, solar cells, and fuel cells. Using a hybrid power source requires sophisticated control when charging and discharging each power source.
This is our controller board for the hybrid power systems. We can use two different power sources to provide efficient and reliable power to the load. One power source is a primary energy generator or storage, and the other power source is a secondary buffer to temporarily store the energy from the primary source.
For example, if the primary source is a solar cell, the secondary buffer can be either a battery or a supercapacitor. In this case, the hybrid power is to store energy generated from the solar cell to maximize generated energy and to provide power reliability. If the primary source is a battery, the secondary buffer can be a supercapacitor. In this case, the hybrid power is to increase the net energy delivered from the battery by suppressing the rate capacity effect. The controller board is composed of three parts. On the front side, we have a voltage regulator circuitry and a charger circuitry. On the back side, we have a control CPU. The voltage regulator is to provide regulated DC voltage to the load, regardless of the voltage variation of the power source. Because the terminal voltage of the power sources changes with the state of charge, load current, and other environmental factors, we need to generate a constant voltage. The charger is a modified DC-DC converter that is added with a programmable constant charging feature. This is necessary to increase energy efficiency when charging a battery or supercapacitor. The control CPU is a low-power microcontroller to measure the voltage and current of each power source and control the power path. We can utilize this board to implement the Maximum Power Tracking Point method, or MPPT for short, for a solar cell. By adjusting output current from the solar cell, we can maximize energy stored in the battery or supercapacitor. We develop an improved tracking method called Maximum Power Transfer Tracking, or MPTT for short, which will be introduced in ISLPD this year. Also, we can mitigate the rate capacity effect by using a supercapacitor as a buffer when we use a battery. For example, a military radio transceiver exhibits a dramatic fluctuation in power consumption. Momentary high power consumption causes a significant low energy efficiency from the battery. The supercapacitor flattens the power consumption and increases total amount of energy from the battery. We perform a collaboration research on the hybrid energy storage system with Professor Pedrom's research group in University of Southern California. The first research result of collaboration will be introduced in ISLPD 2010.
At the DAC University booth, we will demonstrate our hybrid power system with various power source and storage devices.
fourth meeting at the University booth on June 13th. Please find us at the SMU ELPL booth.